This is my second of my videos concerning quadratic functions, and in this video we're going to explore what we refer to as the standard form of the equation of a quadratic function and how they are necessarily graphed. Okay, so I'll have you take a look up here in the top left. We say the graph of y equals ax squared plus bx plus c is a parabola with the following characteristics. And I guess one of the most important things we can mention here is this. This ax squared plus bx plus c form, we want to refer to this as standard form, or any form in which we can identify both this or all of these values. A, which is the coefficient of our x squared, b, which is always the coefficient of x, and then c is kind of nice if we label it c's because it's the constant term. It has no x's, okay? But this can be said about these graphs here. We say the parabola opens up if a is positive, as we kind of mentioned in our last video, and a negative implies that the graph opens downward, okay? Also this, the parabola is wider than the graph of y equals 1x squared. I'll point out that the a value is 1 here. But wider than the graph of y equals x squared if the absolute value of a is less than 1 but greater than 0. In other words, you want to make a note here, but if a is a proper fraction, then it is a wider than normal parabola. And it is narrower than the graph of y equals ax squared or 1x squared if the absolute value of a is greater than 1. In other words, make a note here, we say if it's improper, then you have a skinnier than normal graph. So we say wider, skinnier than y equals x squared. And if a absolute value of a is 1, then we say the graph has the same width of the graph as the graph of y equals x squared, where a is 1. So here's the deal. The nice thing about graphs of this form is that we can always say that the x-coordinate of the vertex is at negative b over 2a. Whatever b is here and then our a is here, if we were to do negative b over 2a, that would actually tell us the x value of our vertex. So one thing I want to point out is this. We say the vertex is at negative b over 2a, comma. Now, to find the y value, this gives us our x value of our vertex, and then to find the y value, we'd actually have to plug that into our function. I know a lot of people don't like the way this looks right off the bat, but really all this is saying is this. To find the x value of the vertex, you just take negative the b value divided by 2 times the a value, and in order to find the y value of the vertex, you just plug that x value into the function and see what you get. Also this, the axis of symmetry is the vertical line x equals negative b over 2a. So this negative b over 2a thing, keep that in your back pocket and memorize the use of it. But the reason why the axis of symmetry has the same exact x value as our vertex is because the axis of symmetry, recall that if here's our vertex, down at the bottom, the axis of symmetry, runs through it. And so it has to have the same x value. Okay, so that being said, let's go ahead and try this out, and we're going to do this for all 3 of these graphs here, but we're going to do it in this order. We're going to identify a, b, and c on each problem. We're going to tell whether it opens up or down, tell whether it's wider, narrower, or the same width as the graph of y equals x squared, and then we're going to identify the vertex, axis of symmetry, and lastly, finally graph the parabola. So to put all these pieces together, we're going to start with this. We say to identify a, b, and c is the best course of action. So we say in this function here, we say our a value is 2, so we say 2, b is negative 8, and c is 6. Okay, so this being said, we say, well, first of all, does it open up or down? This is very easy to tell, as a matter of fact, because of the fact is that 2 is positive. We say it opens up. Okay, opens up. We know this because a is positive. Also, we could also say this if it's wider, skinnier, or wider or narrower, or the same width as y equals x squared. Well, here's the deal. If we were to put this a value over 1, we say 2 over 1, you notice the top is bigger than the bottom on this fraction, so it's improper. And improper essentially indicates that this graph is narrower or skinnier, and I want to put this down as being written this way. We say skinnier than, okay, we're comparing it to y equals 1x squared or y equals x squared. So skinnier than this, okay? So now we're going to get down to the nitty-gritty, that is identify the vertex. So the first thing we want to do is this. We are going to identify the x value of the vertex, okay? And we get this by doing our negative b over 2a. So in this instance, we're going to say negative blank over 2 times blank, or we'll substitute the b value in here. So you can see the importance of actually putting parentheses in here and then filling in the parentheses over 2 times a, and a is 2. So we get this, a positive 8 over 4, we get 2. So what this means to us is this, our vertex happens to be at 2, comma, now the y value. In order to find the y value, we're actually going to have to plug the x value of the vertex into the function. So we get f of 2. So this means we need to go find f of 2. In other words, let's go find the y value when we plug 2 into the function. So we say this is 2 times blank squared minus 8 times blank plus 6, where we're plugging in a 2 everywhere we see an x according to this input. So we'd say order of ops, we get 2 squared is 4 times 2 is 8. 8 minus 8 times, or sorry, yeah, minus 8 times 2 is 16. So 8 minus 16 plus 6 is very important you do your order of operations here. The reason why is because you need to do this subtraction from left to right and with your addition. So we get negative 8 plus 6. All this being done, we discover that 2 is the y value I get when I plug this into my function. So our vertex is at the point 2, comma 2. So we can put this up here on our graph here. So we say 2, comma 2. As a matter of fact, shoot, man, we might have to sketch this by hand. We say 2, comma 2 is a point on my graph. So we say 2, 2. And other things we know about this, well, we say, well, identify the axis of symmetry. Since this opens up, I'm going to go ahead and label my point underneath here. We say 2, comma 2. But the axis of symmetry would have to run through this vertex right here. And so that means that it has the same exact x value as the x value of our vertex, since it's a vertical line running through the vertex. The last thing to do is just graph this. So now here's where the a value comes into play. The a is not slope. However, it does tell us from the vertex how to get to one more point on our graph. We're going to treat it like a slope, but this says we're going to go up to right 1 to find another point on this graph. So if I were to go up to right 1, then I would be at this point right here. And because this graph has symmetry, we would also go up to left 1 and find this point right here. And so this is why we have a somewhat skinnier graph than a normal graph, but this would be our parabola right here. So, the name of the game is this: find the vertex, find the equation of the axis of symmetry, and find one more point on your graph and be able to sketch in the rest of this. Okay, and one important thing to note here is this: it went up to right 1 to get to the next point on the graph, but it doesn't keep going up to right 1, up to right 1, up to right 1. It actually just goes up to right 1, goes through that point, but then tends to get skinnier and skinnier and make a U shape when you sketch this in. So let's go ahead and take a look at these last two very, very quickly. We say, well, the a value is negative 1, b value is 1, c value is 6. So we know this, it opens down. Whoops. So we say opens downward. The reason why is because our a value is negative. We say it is a normal width. Normal width. The reason why it's a normal width is because the absolute value of our a here is 1. We say it's just 1. It's normal width. In terms of the x value of the vertex now, let's find this. We say the x value of the vertex is negative b over 2a. So we get negative this over 2 times this, where our b value was 1. And our a value is negative 1. So we get this. Negative 1 over a negative 2 is a half. So what this tells us is our vertex is at a half, comma, whatever we get when we plug a half into the function. So we do actually have to plug a half into this function. That's not a horrible thing. It's not ideal either. But we say negative blank squared plus blank plus 6, where this is a half. And so is this. When you square a fraction, since you multiply straight across anyways, and squared means take it times itself, you're really squaring the top and the bottom of the fraction. So we get 1 squared is 1, over 2 squared is 4, plus a half, plus 6 wholes. And if we were to rock a common denominator on all these, which is 4, we'd get, excuse me, negative a fourth. Now if we turn a half into a fourth, that's 2 fourths. Plus now 6 wholes into a fourth would be 24 fourths. So adding all these together, we get a grand total of how many fourths? Well, negative 1 plus 2 is 1, and 1 plus 24 is 25. So the thing we can do here is this. We say 4 goes into 25 6 times evenly with 1 left over. So it would be 6 and 1/4. So our vertex is at the point 1/2, comma, 6 1/4. And this also means then that our axis of symmetry, AOS, is at x equals a half, since it has the same x value as our vertex. So I'm going to kind of use the space down here we reserved for this last graph, and we'll just make it this graph here. But we say if we were to sketch this in, we'd say that the vertex we found was at the point, comma, 1/2, comma, 1, 2, 3, 4, 5, 6. But we say 1/2, which is about right here, comma, 6 1/4, so a little bit higher than this. So yeah, there. So this is our vertex. We always want to label this. We say 1/2, 1/2, 6 1/4. And so the axis of symmetry also runs through our vertex, and we can label this x equals 1/2. And then we also know that this opens downward. The a value is 1, so we say -1. So we say -1/1 means that it'll go down 1 point here, 1, and then right 1. Now, it doesn't keep doing this, but it does mean that that point is on my graph. And so I can at least get a good rough sketch of my u that keeps getting steeper and steeper because we know it goes through those 2 points. But that is a quick rough sketch of these graphs. Cheers.